Hey guys, what's up? Eddie Alho here with KissAnalog.com. Today I want to do a quick review on this multimeter, and although it's been reviewed a number of times on the web, I just want to add a couple twists to that. Maybe add a little extra, something hopefully that's helpful. So I'll take some measurements. I'm going to show you some things to think about when you're using this meter or pretty much any multimeter. And hey, nice big display, right? Okay, let's jump to this review. Hey, just as a reminder, kind of a safety reminder, before you connect your probes to your circuit, make sure that you have them in the correct places where you need them for the measurement you're taking. Voltage over here, or microamps, current over here, okay? Make sure you have them in the correct place and the dial in the correct position. Don't be switching them around with your leads connected to your circuit. Just a safety note, something that is in their little book telling you to do so, so be careful, okay? Okay, so let's run through this quick review on this multimeter here. Much less expensive than this, about 25 bucks, 24 bucks and some change, I think. Has a nice little bag, which is always nice to keep test aids, and actually this would be nice to put in say your glove box in your car, just somewhere where you might need something small and portable, or heck, on the bench works great too probably. Let's take a look. There's a little guy there. Oh, small handheld, fits nicely, not too teeny. Nice solid clicks, so it feels pretty solid. Buttons feel nice. Alright, multi-function. Each button does at least two things. Some of them do three, it looks like. Let's see what else we get in this. Wow, two sets of test aids. Pretty cool. I don't know if I've seen that before. Okay, let's just set that aside here. Might want to refer this manual in a minute. Here, let's just look at these leads. They feel a little bit on the, compared to the Fluke, they seem a little bit on the smaller diameter. Actually, these leads here I'll pull those out. These have a nice feel. These are a little bit, they do have a little bit cheaper feel to them, to tell you the truth. Where the Fluke has kind of a soft grip, and it has this kind of flex point here that kind of keeps you from working this loose. Fairly sharp. This guy also has the same kind of flex point, even nicer maybe. Has these little dudes. I'm sure the Fluke came with them one time. It's Cat 2 600 volts. Yeah, it repeats it there. I'll just take them off for now in case we need it. Here, let's plug them in. Okay, we got these little guys to keep those from getting all bent and deformed. I don't know if you've ever done that before. Pulled out leads and saw them all smushed up. Anyway, okay, well, that felt pretty solid too when I pushed them in. They went in pretty easy, but they feel pretty solid at the same time. Looking down the side there, it looks like the kind of split collar, probably reinforced with the plastic or vinyl or whatever this is. Now it does say 600 volt Cat 3 or 1000 volt Cat 2, 200 milliamps max. And between these two you get a fused 10 amps. Well, that's interesting. The microamps is on this. You don't see that often. Usually the current ones all have separate inputs. Maybe it's because microamps, they're allowed to have high impedance. Usually you want your voltage probes to have high impedance. When you touch your circuit, you don't want your probes to affect your circuit, so you want them to have high impedance. So yeah, that's interesting. Okay, 9,999 counts. So like 4 digits. It's pretty decent. Yeah, it looks like, okay. See 4 full digits. Okay. So you have your volts and DC and AC on the same thing, and then hertz. I'm going to look in the manual to see what percentage is. Millivolts, AC, DC, ohms, and then you have the beeper select, and a lot of people like to see how fast this reacts. Not super fast. Fast enough. I think if you're ohm checking things, you're not going to be sitting there waiting for a beeper to go off. Where I've had meters that actually, I had an expensive meter actually that you touch it, you have to wait a quarter of a second or so. Even a fraction, you know, that kind of time was kind of annoying when you're checking a bunch of pins. But on this one, I think every time you touch, you're going to get a reading. I don't think that's, you know, there are some meters really quick. I just noticed there's a little bit of a contour here in the probe, so when you're holding them, that's kind of a interesting idea. That's neat. Haven't seen that. 10 amps rated. Okay, so you can put 10 amps to these. I was kind of wondering if that's what these were for, is to do the amp rating. Here, let's look at this lead set. Wow, there's a cool little bag of stuff. Here, let's see what we got here. Okay, you can make this a multi. Oh yeah, so all four can be used as kind of multi-purpose. You can make test leads with these. That plastic fill is kind of hard and plasticky. It says 1000 volts cat. Just says cat, 1000 volts. I don't know what category it is, but it just says cat. And these are the nice booties with the solid screw ends. So I guess, yeah. Well, you know what's neat is you can put one of these on each end and use them as test leads. And you got 2 reds. So that's pretty cool. So you can just use them as jumpers. You don't need to use them as probe leads. See if I can open up this little bag. My fingers don't want to. Alright, there we go. So first of all, we have these 4 little dudes. These guys are your banana jacks. It's like 4, it's like split twice, so it's, and these things are solid. And yeah, that does, there is a decent amount of tension to push those in. So there's 4. You can go banana to banana. You can use these to, and those are solidly built too. They're not going to bend easy. Those are pretty nice. Then wow, you got little dart tips. That's nice. If you don't need to have these little plastic things, just want to use those. Huh, okay, that's cool. Let's get that out of the way for now. Guess I'm put them up here in my pocket. Alright, we'll get this stuff out of the way. Alright, so yeah, like the leads. These are nice, soft, and you know, that 1000 volt PVC, pretty nice, 105C rated. Okay, what was that, 3.5 millimeters? Just kind of repeat myself, I guess. And let me look at the percentage thing. I'll be right back. Okay, so the percentage, I guess I should have guessed. It's on the hertz here and the hertz here. So that's percentage duty cycle. And you know, tolerances for a meter like this are pretty darn good. I mean, you know, I don't know how many places you need, but here, let me bring this in. So you can see it, I think you can see 0.5%, 1%. So DC AC voltage You know, everything's 1% or better, 0.5%. Resistance to high ohms are 1.5%. And then capacitance is 2%. Now this is interesting. I think it's funny the way they wrote that. Okay, it's 0.001 nanofarad. Otherwise, that's 1 picofarad, right? And then that's it. You go from 1 puff range down to 0.001 millifarad, which, yeah, that's 1 microfarad, right? So it just sounds better when you say millifarad, I guess. Anyway, so that's the range. Okay. Okay, did you hear those 5 beeps? That means we have 1 minute before this thing powers off. It waits 15 minutes and then powers off. And 1 minute before it gives 5 beeps, that little beep we heard. When it turns off, I think you can hit either one of these buttons. We'll test that functionality. As far as testing how accurate it is, measuring volts and ohms and current, I'm not going to do that because I trust that, you know, unless the thing's broken, I trust that it's going to come at least close to what's specified. And I don't think I have references any better than 1% that I can show. But if you like to see that stuff, I can do it next time. But what I do think, there he goes. Yep, you just hit a button, it comes back up. Okay, now if you want to disable that, when you power it on, just hold the button down as you power it on and it'll disable that power off mode. But just be aware, you're going to run down your battery if you forget to turn it off. But, you know, there's times when you're taking readings, right? And every 15 minutes you don't want to have to worry about that. So sometimes it's nice to turn it off. Okay, there is something that I think's very useful thing to test, and because every meter is different, and when I looked here, it just gave you a check mark. Yep, we checked diodes. But, you know, if it puts out, say, 1.5 volts, sure, it'll check a 0.7 volt diode. But what if we want to check a 2 volt LED or opto isolator or something like that? So I got the fluke over here. Let me put on DC volts. Can you see the fluke? Maybe I'll put the leads here, prop it. Let's see, what am I doing? DC volts. And we're in diode mode here. So this guy's timed off too. 3.24 volts. That's pretty cool. So there are 2 AAA batteries in here, and what it looks to me like is that it puts those batteries in a series to give that voltage out, which makes me think of something else. Okay, I think it's a really cool feature that it has the hertz. I think that's way cool. And I was thinking I was going to have to get my scope, but we can check that with here. Let's check how many volts it puts out. Well, and the other thing is I'm curious how it works. Okay, it goes from 50 hertz, and I think I saw that it went up to, here, let's see, it was range or select. Okay, here we go, 100, 200, 3, 4, climbs up 100 hertz at a time, 2,000, 3,000, and then 5,000. So it goes from 50 to 100, it climbs up to 1,000, and then climbs 1,000 up to 5,000. So 50 hertz to 5,000, that's pretty neat. Well, that's actually pretty cool. Okay, so let's see how many volts it's putting out. I need to go to AC. And it's almost 1.6. So almost 1.6 volts. Let's see, what else can I do on this? I was wondering, here, let's go to my hertz. And it says 50 hertz, 50.02 hertz. And down here it says 1.58 volts. I don't know if you can see that, but I get a little bit closer here. Make sure the glare is not hitting it. Here, let's try this. I'm curious. I don't even know how high this will go in reading frequency. There's 100. Still, it's 1.57. 200, 1.57. Boy, it's pretty darn accurate. 300. And I'm sure that this is going to be within the tolerance of this, so that's what I mean by me calibrating the meter. I'm not really set up to do that. I think we've got to trust certain things, but since this is kind of one of those features that's not well spec'd, it looks like it holds 1.54 pretty solid. Look at that. The Fluke was able to keep up at 900 hertz. There's 1,000, 2. Okay, now the Fluke is starting to drop off 1.47. That's the bandwidth of this meter, and we'll look on the functionary. That's why I have it out here so we can test the bandwidth. But see how it's falling off? I'll bet this guy's still putting out the same voltage. But here, let's just continue. Okay, at 5,000 we've dropped to 1.4. We're gonna use this generator to see if that's accurate, because see if the voltage really did drop it down like that, or if it's back to 50, or if it's really 1.56 or 1.57 almost. Okay, so that's pretty cool. It puts out frequency. We check the diode. Oh, the light. Let's see. You have to hold it down for 2 seconds. Kind of looked at the manual, and I don't know if you can see that, but it's pretty, I think it's pretty bright. I mean, it's fairly evenly lit. There's kind of a hot spot here with LED. I'm assuming it's an LED lighting it up. So that's not bad. Then you have to hold it down for 2 seconds and turn it back off. Now I'm sure that's going to eat up the battery if you leave that thing on. Okay, so let's check out the Fluke first. Let's see how. I'm going to put out 1 volt on this thing. Amplitude. So that's 2 volts peak to peak. Okay, so that's 1 volt peak. That should be 0.707 RMS, right? And it should be, okay, so here we are. You can see that. It's 1 kilohertz, 0.712. Okay, so I'm gonna creep this up and see if it does. I'm gonna go to 2 kilohertz. Whoops, sorry, it's still in amplitude mode. Okay, this is my Signet SDG810. Goes up to 10 meg, so we're gonna go up to 5K easy. Let's go to 2 kilohertz. Okay, 0.711. Now let's see if 3 kilohertz the voltage drops off. No, it doesn't. Still 711 at 3K. So I think this guy really does kind of drop in amplitude a little bit. Okay, let's go to 4K. Now we're actually just testing the Fluke. Then we're gonna test this guy. Same way. Okay, we're still getting the same voltage reading, 0.711. So 5K. Wow, that's pretty okay. Let's just jump up to 20K. It just dropped to 0.709. So I'm gonna go to 30K. Wow, this is 0.708. So this guy, okay, let's try 50K. I actually don't know what the bandwidth is on this guy. 0.707. Okay, we're gonna do 100K. Okay, it's definitely starting to drop off. It's 0.694. So I'll bet you 150K. Probably drop off pretty. Well, 0.647. 300K. Okay, we're half the voltage, 0.383. So it's, you know, I mean, that's pretty impressive. A lot of multimeters don't go past 1 kilohertz, true RMS meters. So I mean, well, you know, you're paying a lot of money for this guy. All right, now let's try this guy. We'll drop it back down to 1K. And we're going to assume that it has a bandwidth of at least 1K. From the fluke, we know what voltage we're putting out. And so now let's go read. Now, you know what? Another thing in the manual, it says disconnect before changing the setting. So I'm just going to go ahead and do that, even though I know this generator won't hurt this meter. I'll just follow the rules on that one. Okay, I'm going to go to AC. Okay, it says True RMS Auto. Whoops. Lead popped off. Sorry, bumping the camera there. Okay, there we go. 713. That seems to be pretty close to what the fluke was reading. Let's go to. You know, I could probably put both these guys together so you can. Well, we already kind of. Shoot. All right. Sorry. We're just gonna do this a little quicker. Okay. I'm going to jump up to 5 kilohertz just to see if it'll go to 5K. No, it's dropped off to 138 millivolts, so let's go to 2K. It's about 0.7, I'd say. So I'd say about 1 or 2 kilohertz, you know, is about as good as you're going to get before you start dropping off. So 3K, it's probably going to be, yeah, it's 0.5. So around, you know. So anyway, that's something I want you to be aware of when you're measuring frequencies. If you're looking at audio frequency up to 20K, most multimeters, unless you've spent some money, won't give you accurate readings. Okay, and by the way, this meter is putting out a sine wave. We're doing sine wave with these guys. Let's just go to 1K, and let's go to square wave. Okay, we're seeing about 0.934, and I'll bring this meter over. Let's get the fluke to just see what it thinks. It says about one, whoops, that's 1K. It was agreeing that I had the right frequency, and about 1 volt AC. And this is 0.934, so 1 kilohertz is doing the square wave pretty good. So let's do 2K. And we're seeing about the same roll off, so that's kind of impressive that a square wave, it still reads. So you know what, sine or square, it's right around 1 to 2K. You're getting good readings. That's impressive. That's a good true RMS meter. That with the square wave, it still gives accurate readings. Let's go ahead and read frequency with it. So see, it's going 2.99. Now let's go to 10K. Wow, that's great. 20K. All right, let's do 100K. Okay, it didn't keep up. After 20K, let's go to 50K. All right, 50K, it's good. 80. No. 70. All right, so that's something that's probably in the man. Okay, 60K, it's hanging in there pretty good. I'm gonna reference this real quick. All right, so reference in the manual, it says 0.001 megahertz. That's, I don't know why they just can't say it. I mean, just because they're using megahertz doesn't make it sound more, you know, does that sound better than if they just said 1 kilohertz? Because that's really 1 kilohertz, right? And the next range down below that's 0.1 kilohertz. So 1 kilohertz, you get a very accurate reading, which we've seen that. So, but you know what? We're actually getting a better reading than, I mean, it seems like it goes about 60K, so that's done, you know, better than what they said. Let's do the percentage. Okay, 45%, which heck, you know, I've got 50% duty cycle, so that is pretty darn good. I'm going to drop down 20K. Now it's 49. So you know what? This guy does better than his spec. Gosh, fairly impressed with that. I mean, you know, factor goes up to 1 kilohertz, you know, that's not bad at all, because some of the less expensive flukes will only do that. So, and you know, the price this thing is, that's fairly impressive. Now there's something else I want to show you on the meter. Okay, let's disconnect this guy. We won't need that guy anymore. Let's put this in current mode. Now first of all, when you go to current mode, I was expecting it to holler at me about not having the leads in their proper place, but it doesn't. So, you know, again, inexpensive meter. So now microamps, this is the correct spot, but milliamps, it's not. So I should be over here. Anyway, so the meter does say disconnect the leads before you change this, but you also need to make sure you put that in the proper place when you're reading current. And then when you're done reading current, before you read volts, I'd put it back, because even though it might have some protection in there, you might damage it. Okay, what I want to show you is, let's put this on ohms. And when you're reading current, I just want you to be aware of something. Now, I get my fingers out there. Okay, that's 101 ohms. So when you're reading microamps, remember, you have 101 ohms in series of your reading, okay? The meter's putting 101, you know, ohms in there, okay? Now let's do the milliamps. And that's about 31 ohms. And there's actually, you know, if I hold my leads together, I got about 0.26 ohms. So, and so it's actually a pretty small shunt resistor in there. I mean, at 10 amps, it can't have a very big one, right? Because that'd create too much heat. So it's pretty small. But in microamps, now here, let's do this. Let's change the range and check. Okay. So there's I'm sorry, I gotta hold that solid point. That's me moving around, 0.3, 0.5. I don't really see it moving too much. I think in this 10 amp range, they've got a pretty small shunt resistor. Sometimes there's more than one resistor, and probably let's go back to the microamps. Okay, we're 101, right? There's 101. Hit the range. Okay, I don't see it changing resistors. Sometimes they do, because they get better accuracy if they change. No, it's about 101 every time, it looks like. Okay, so just be aware of that, okay? Now, when you're reading ohms, this guy's going to put out a little bit of voltage, right? So he can read some ohms. So let's see what he puts out. About a half a volt. So just be aware of that. Okay, so in volts, when you're checking volts with this meter, you don't want it affecting your readings, right? So you want, you know, meg ohms of impedance, right? So what you'll see here is, you know, the typical 10 meg ohms. So it's got 10 meg ohm resistor here. So when you're taking voltage readings, just remember that, you know, that's 10 meg. I mean, that's typical. So just be aware of, you know, how your meter affects your readings. Okay, I think that does it for readings and so on. I'm trying to think if I missed something. I should have a checklist, right? All right, here I'm gonna pop the hood. I might cut this out of the video here, but let me put these in my little pocket here. Actually, I got a little magnetic thing there to hold these guys so don't lose them. You know, the one interesting thing about this, when I went in here and put batteries in here, I had to put 2 AAA batteries in there, and when I did that, I did not see a screw in there. I thought I'd have to remove the batteries. I wanted to make sure the meter wasn't DOA before we start this video. I think I got to pop this out of there. Probably can't do it with my fingernails, or lack thereof. You guys are probably chuckling at me right now. That's all right. Usually, I'll tell you what, a lot of these meters come apart a lot easier than this one does. And let me just show you the kickstand. So there's one screw holding the battery, and it holds the kickstand in there too when you remove this. Now this plastic is fairly, it's not super, well, it has no flex to it. I was kind of afraid to bend it actually. But it has no flex, so there's some strength. But yeah, you notice that the batteries are still in there when you take it apart. I thought that was kind of interesting that it doesn't force you to remove the batteries first. Alright, well, you may have seen teardowns of this before, so I won't spend a lot of time on this guy. It looks pretty well. Here, let me zoom in on this. Move this guy out of the way. Alright, I won't spend a lot of time on this because you've probably seen teardowns of this meter before. Just giving another viewpoint, I guess. This meter does have the heavy duty beefed up trace here for the fuse. It has this jumper here. That must be for the 10 amp readings. Yeah, that's what that is. A 0.1 ohm resistor. 0.01 R. Probably can't read that, but that's what it says down here. So that's your 10 amp. Yep, that's your 10 amp fuse, and there's the resistor. So what I want to say, I'd have to look up this fuse, but just this pure size of it, I would not want to have something with a lot of voltage. When that fuse opens, I have a hard time believing. When a fuse opens, there's 2 things that happen. First it melts, and then it blows open. And when it blows open, you know, it needs to have enough distance between those 2 ends when the molten metal separates to quench the arc. So the arc goes out, because low voltage even will not arc. It won't arc when you hold the terminals close to each other, but when you're holding them and separate them, you'll get an arc. So you got to have a certain distance, and that fuse just looks too small. So I would be wary of using this around high voltage, high current. Mostly high voltage, I'd just be kind of careful. If you're doing 10 amps at 100 volts, that's a lot of energy. Okay, so this little pad here, I don't know why it's here. The only reason I could see why it'd be put on back is for testing at the factory. But I think, from what I've seen in other videos, that's for manual range. This is a PTC right here. It's kind of interesting. It's bent down to touch this chip, as if this is going to get hot too. I don't know if they're trying to do a double protection method there to try to protect this guy too. I think he'd be dead before he opened this guy, but this so PTC is resettable, but it's very small and looks like a ceramic type, and so I don't know what the voltage rating is on that either. So again, as far as the transistors, there's 2 surface mount transistors down here that everything looks well soldered. I can just say that looking at the board, it looks like it, you know, some quality went into this actually. I think I've seen other videos where that might not have been true, but the one thing I can say is when I look at the way the fuse clips are clipped in, from the top side I don't see solder fill. So I don't know if they're just physically clamped in or if there's any solder fill, but I don't see solder on those pads. And I think if they're soldered from the bottom side, it would have pulled up in to the pad. But yeah, I don't know. They may not be plated holes, so maybe that's not true. Maybe they are soldered on their side, but I don't really care to pull the seam further apart. Sorry about that. It's ANENG AN8008, and that's what it looks like today. This thing was bought later part of 2018, so I don't see any date codes or anything like that on the board. The fuse does say it's 250 volt rated, so that could be true. It just, you know, this PTC should be down here. If there's any TBS diodes, which maybe that's what this is, that's placed close to the fuse, so that's probably placed well. Small though. Anyway, hey, it's an inexpensive meter, so they've done some protection in there. It does have a little buzzer right here. Automotive stuff, I think this thing would be great. This guy, just to let you know, this guy actually says made in USA. Okay, I'm kind of impressed. I thought maybe they moved that manufacturing to China, but anyway, all right guys, you know what, I would say that for 25 bucks this looks like a nice setup, and definitely something you can use around low voltage electronics, and has some really cool features. This little square wave's really cool, so, and it reads pretty accurately up to at least 1 kilohertz, probably 2 kilohertz before it starts tailoring off too far. So, you know, boy, nice big display. If you need something around the house, you work around the furnace, if you're reading 115 volts, you know, I don't know. I don't know. Anything around the mains voltage and that, it's probably okay, but I feel safer doing that kind of stuff. And you know what, it doesn't have to be a fluke, it's just when I don't see the protection in there, I think the key is put this in voltage mode, AC voltage, and read your 115, you're probably fine. But just make sure you do what they say. Make sure it's in the right setting before you apply the test leads to your measurement. Okay? Alright guys, hey, hope you liked that. Hope that was of any value to you. And give me a thumbs up if you did. That helps me a lot. And okay, thanks guys. Have a nice day.